Hello and welcome to Partially Redacted, a podcast where we discuss privacy and security engineering and related topics. I'm your host, Sean Falconer, and today I'm joined by Liz Acosta, developer advocate at Skyflow, and we'll be talking about secure multi-party computation. Liz, welcome to the show.
Hi, it's a pleasure to be here.
Awesome. Thanks so much for doing this. So like many people that end up working in developer relations, you have an interesting background. Engineering was perhaps maybe a second or maybe third career for you. Can we start by having you introduce yourself, share a bit about your background and what you do today?
Sure. Yeah. So hi, my name is Liz. And as you mentioned, I'm a developer advocate at Skyflow. So I've been working in developer relations for a couple years now. Before I pivoted into DevRel, I was an engineer at Twilio for about 5 years after attending a coding boot camp in San Francisco. And before that, I was a social media manager and contributor to these online magazines called Dogster and Catster. So yes, like Friendster, but for cats and dogs. My degree is actually in filmmaking and fine arts. And I've done just a bunch of odd jobs ranging from dog walking to wedding photography and even writing for a celebrity gossip blog. So not exactly your typical path to tech, right? But as someone with ADHD who is drawn to many different interests, I've finally found my place in developer relations. It's the kind of role that really seems to embrace many of my neurodivergent traits, gives me the freedom to work some of the more creative skills that I have, as well as the technical skills. And there's always this opportunity to learn something new, which is what really excites me.
Yeah, absolutely. I think developer relations, as someone who's also, found their way into that space, it kind of pays to be a million miles wide and an inch deep on lots of things versus if you're deep into engineering, sometimes it's better to be a million miles deep and maybe only an inch wide. And I think this combination of film, social, engineering, writing is kind of like the right combination of skill sets to be a great, developer advocate. So, now you're working, you work for Skyflow. How did you kind of get interested in data privacy and what led you to joining Skyflow?
Yeah, good question. And it's interesting because the answer to this question is pretty common among lots of people who work in privacy. But I kind of stumbled into it. I wasn't exactly looking for it, but here I am. And I think part of that is because it's still a really new field that has arisen in response to some of the more visible and more frequent breaches in privacy that we're seeing. And I found myself drawn to privacy as a right, like as a human right. I don't know about you, but more and more I find myself filling out something online and wondering, okay, well, where's my data really going? Do I have a say in where it's going? Like, can I choose not to have it go there? And like, how is it going to be used? But at the same time, we have to recognize, and I recognize, that data has value beyond just like targeted ads, right? We can use data to form the foundation of some pretty important innovation. And I think about, so I'm a cancer survivor, and I think about that. And my type of cancer was rare and aggressive. And so there wasn't like a standard treatment plan. And what we did is we used data to make some of the educated guesses that we made about my treatment. And as a result, I am 6-7 years in remission. So that's where data is important. And so the question becomes like, how do we reconcile all of this, right? Like, how do we respect the individual without limiting that innovation, without limiting like the potential for solutions that arise out of data? And I think what's interesting about Skyflow is that Skyflow is one of the answers to some of those questions.
Yeah, absolutely. And first, congratulations, obviously, on being a cancer survivor and being in remission for the last 6 or 7 years. And I think you made a really great point that sometimes we overlook in the midst of reading all the headlines about data breaches and thinking about how our data is being used. We tend to, I think, a lot of times associate that with the companies that are using data for generating ad revenue. But there's lots of other uses of data that are really, really hopefully wonderful uses of data that are going to allow us, to help people like it was able to help you. And even beyond that, data is what fuels uh, analysis and clinical trials and lots of things in the medical space and lots of things in a variety of different spaces. So it's not just about ads, but sometimes we can find ourselves thinking purely about that type of stuff. So we're talking about secure multi-party computation today. And you wrote a great blog post about this topic, which we'll add into the show notes. But to begin, what is Yao's millionaire problem and how does that relate to secure multi-party computation?
Yes, the famous millionaire problem. So Yao's millionaire problem is a scenario that was introduced by Andrew Yao in his paper titled Protocols for Secure Computations. If we adjusted for inflation, it might be Yao's billionaire problem, but that's neither here nor there. Either way, the scenario is this. There are two millionaires at dinner. We'll call them Alice and Bob. And they decide that between the two of them, the millionaire with the higher net worth is the one who's going to pay for dinner that night. The problem is they don't want to tell each other their net worths, and they don't trust anyone else with that information. So they don't trust each other. They don't trust a third party. So how do they figure out who pays for dinner? Because it'll look pretty bad if they just get up and leave, right? They need to pay for dinner. So then the question really boils down to this, right? So how do they compute some kind of output, i.e. figure out who pays for dinner without revealing any of those inputs, right? And so that's the basis of secure multi-party computation. So that question is essentially how do we arrive at some kind of output that all of the participating parties I think they're interested in that output, right? And the participating parties are also contributing input, but how do they keep the input secret from each other while getting an output for all of them? Then that's the question that forms the foundation of secure multi-party computation.
And I can't tell you the number of countless times I've been sitting at dinner with my, billionaire friends, and we had, this type of conversation to try to figure out which of us has a higher net income. So
yeah, always, right?
Very relatable. So it sounds like essentially the crux of it is you want to make an assertion essentially, or you want to answer a specific question, but you don't want to give up essentially whatever private details are needed in order to actually answer that question.
Precisely, yeah.
So how, in practice, how does secure multi-party computation solve this problem?
So I think a good place to start is just with an example of how we would do this. So I'm going to start with a kind of simple example, right? Just because high level, it's in your brain. It's kind of a fuzzy concept, right? Where you're well, why would I need to do that? What is the point of this? Secure multi-party computation. Why do I want to do this? How is this applicable, right? When I was researching it for the blog post, definitely at first I was this is kind of fuzzy, but the more examples I found and got into and really started to understand, the more I could see its use. So we'll start with an example just so we can see how it works in some kind of real world application. So for this example, we're going to talk about 3 siblings. let's call them Gabriella, Marisol, and Wanderson, right? Each sibling receives a weekly allowance. However, the siblings don't know how much allowance the other sibling gets, right? It's a secret. I don't know what their parents' thinking is regarding this, but it's a secret. But we know what they get, right? And this is kind of typical to like, you don't generally know your coworkers' salaries, kind of like that, I guess. So the siblings want to try to figure out the average of their allowances without telling each other how much each receives, right? So in this space, Gabriella receives $15, Marisol gets 20, and Wanderson gets $10, right? They don't know that among each other, but they want to try to figure out the average, like I said, without telling each other. So one way that they can solve for this is to tell each other just a portion of their allowance, right? So not the full amount, but just part of it, right? So for instance, Marisol tells Gabriella that her allowance is $11, and then she tells Wanderson that her allowance is $1, right? So neither Gabriella or Wanderson knows that Marisol is actually receiving $20. She just gives them a portion. Marisol knows the difference, so she knows that the difference between the two amounts she told her siblings is $8, right? So to review, because I know this can be a little hard to hold in your head all at once, Marisol has told Gabriella that she receives $11. She's told Wanderson that she receives $1. That's $12 together. Subtract 12 from Marisol's $20 allowance, and we're left with 8. Okay? So hang on to those numbers. Sweet. There'll be a test on this later. So let's stick with Marisol here, right? From her point of view. So in this, secure multi-party computation that they're performing, Gabriella then tells Marisol that she receives $10, and Wanderson tells Marisol that he receives $2. So what does Marisol know at this point, right? Well, she knows that her sister's allowance is either $10 or more, but she doesn't know that it's $15. And she also knows that her brother's allowance is either $2 or more, but she doesn't know that it's actually $10, right? So they all have a portion of each other's allowance amounts. Meanwhile, Gabriella and Wanderson have shared portions of their allowances with each other as well, right? So at this point, each sibling has a sum of 3 numbers, right? In the case of Marisol, she has a sum of $20. And that is the sum of the allowance amounts her siblings have shared with her, which is $10 and $2, so that's 12, plus the difference between the amount she disclosed to her siblings, which is 8. So now the 3 siblings add up their individual sums, right? So which comes out to, and these are the sums that they get at the end of like adding up the allowance amounts they know. So they get 16 plus 9 plus Marisol's 20, right? That equals 45. Doing that right? Yes. If we divide 45 by 3, which is the number of siblings, then we get 15. So that's the average, right? Now they know the average allowance between the 3 of them. They know that it's $15, but they don't know how much each sibling receives. That's still a mystery. However, now they can bring this information to their parents at dinner time and demand a raise. So I hope that it's kind of a simple. While it is a simple example, it's still of a complex topic. So I hope that made sense. And let me know if there's anything I can clarify there.
Yeah, so it sounds like at least in the allowance example, they're using some, kind of mathematical tricks around the, like subtracting some values off of their total sum to come up with an aggregate that allows them to actually compute the average without actually revealing the underlying values, only revealing essentially partial information about what that person's actual allowance is. Is most of the approaches to secure multi-party computation using some sort of like little like mathematical tricks to be able to hide essentially the real values and only reveal sort of partial information?
So there is a lot of math involved, but there's also protocols around like who has access to the information as well, right? So in the example of the siblings, like that's a very, very simple example. And you might even argue that it's not like truly secure in air quotes multi-party computation because, in cryptography, which secure multi-party computation is a subfield of, we're constantly asking ourselves, like, who is the adversary and how do we protect ourselves from the adversary? How do we know that the information that we're receiving is correct and right? So in truly like secure, in air quotes, multi-party computation, there would also be some kind of method or protocol for checking that the amounts that the siblings are sharing are actually correct, right? Like, because you're right, like they could trick each other, they could lie to each other, right? And in this example, like, if we, without getting into too much detail, but there is one sibling who just tells the whole amount to everyone else. And then there's like another sibling that subtracts an amount, right? So there are like these algorithms that you use with secure multi-party computation. And then in addition to that, if you want to add another layer, there is then that's when you start asking among the participants like different kinds of questions or these Boolean questions that are like, is this actually true? Is it not true? To check against each other. And you can see how it starts to get very exponentially complex, which is part of the reason why, even though the concept of secure multi-party computation has been around since the late 70s, early 80s, it wasn't until like early 2000s that we started to see any kind of real practical application of it, because the mathematics and the resources that required to perform these kinds of operations is so resource intensive.
Mm-hmm. Yeah, I think that's a great explanation. And since you mentioned only recently we're starting to see practical applications, what are some of the like practical uses beyond sort of these thought experiment toy problems that we're talking about?
So like I said, like these questions, mathematicians and computer scientists were asking each other these kinds of questions in the late 70s, early 80s. It all kind of started with the idea of like, how do we solve mental poker, basically, right? Which is like, how can two people shuffle a deck of cards, but then how do we protect against those players cheating? The math for that gets a little complicated. And it's all about kind of like, okay, like one person has a deck of cards, they shuffle it, but then they scramble it with encrypt it, and only they can see that, right? And then pass it to the next player, they shuffle it and then encrypt it. And there's these levels of encryption that, the explanation is beyond the scope of this podcast, but that essentially safeguard against cheating, right? So this is all to say that back then they were trying to figure out how do we create online poker. But so that was like 70s, early 80s. But there wasn't an in between, So that was late 70s, early 80s. Somewhere around like early 2000s, there were a couple of like toy programs that were using secure multi-party computation. One of them was called Fair Play, I think, but it couldn't do anything super complex. There wasn't real application of secure multi-party computation until 2008 with the Danish sugar beet auction, where it was an electronic double auction to find the new market clearing price of sugar beets, where the auctioneer was a computer program. And I'm not sure the exact details because my knowledge of Danish, agriculture, and sugar beets is not extensive. So I can't get into too many details. But essentially, like a contract had run out, but they needed some way to bid on the sugar beets without revealing like who was bidding and how much they were bidding. And that was like the first time in 2008 that secure multi-party computation really was used in this kind of like very real world situation that wasn't just like, well, how can we like, how do two millionaires who figure out who pays for dinner, right? So yeah, and since then, we've started to see it in advertising, going back to targeted ads. Yes, that is a place where that's used, as well as in machine learning, right? For the models that they're training the AI on.
Hey there, Sean, host of Partially Redacted. You probably guessed that since at this point in the interview, you probably recognize my voice. I've been told for years that I have a face for podcasting, but no one has mentioned whether I have a voice for podcasting, so sorry about that. Hopefully, the awesome guest makes up for it. Anyway, if you're enjoying this episode, please support the show by subscribing and telling your friends. You can also join the Partially Redacted community at skyflow.com/community. Okay, that's enough for me. Back to the show.
Yeah, so you mentioned a couple of these scenarios, like the real world applications. Is there kind of like particular use cases or scenarios where this particular approach is going to be like more useful than in other scenarios?
So, for better or for worse, a primary example of secure multi-party computation out in the real world that's being used that you've probably like participated in is Facebook advertising, right? So companies that want to advertise on Facebook and elsewhere can employ Facebook user data to help them make advertising decisions, right? However, Facebook is required to protect user data, right? We are past the age when like we're just giving data away. And so what they do is they can provide that user data, but it's encrypted and it's de-identified so that the companies that then use it don't know anything about the users. And then the companies and Facebook can work together to make these advertising decisions, right? Other scenarios include, like I said, research, especially machine learning, model training, and encryption key management models that are designed to secure data against hackers, right? By distributing vulnerability along a wider attack vector. And that's done by, and there's another example of this that we didn't get into, but so when it comes to encryption key management, we can think about the example of the siblings and their allowance, right? But if instead of them just like telling each other the amounts that they receive, if they also had like put the amounts, like their allowance amounts in like a locked box and then gave the key to another sibling to open that box. And so what happens there is that you have not only all this information portioned out, you also, and distributed, you also have the access to that information portioned out and distributed. So in the case of like protecting against like hackers, or even like, let's say you're one company, but you have several verticals and people are using data across those verticals, but they're only allowed specific parts of that data. This is one way to do that. Does that make sense?
Yeah, we actually touched on this in a recent episode on backups and disaster recovery with how Druva's system works, where it's not necessarily exactly secure multi-party computation, but it's kind of the same spirit of this, I believe, where their backups, they basically, instead of having one backup of your entire system that's encrypted, and then they have, some one encryption key that unlocks it, they take those backups and they basically break them up into all these different small chunks, and they put them in different locations, and each one's encrypted in a different way. And that way, even if someone gets a single chunk of that information and like somehow gets the key to it or brute force unencrypts it, they only have this tiny little bit of a fraction of the actual information. And it doesn't really, basically partial information is far less impactful and undesirable to an organization than just, everything essentially.
That everything.
Yeah.
Yeah, precisely.
Mm-hmm. What are some of the challenges and opportunities do you see for wider adoption of secure multi-party computation in the future? What are like the limitations essentially today that are preventing wider adoption of this?
Right. I think that there's a couple of things that are challenges. One is that, like a lot of things in tech, people want to see it in action, right? They want to know, why should I trust this new pattern, right? So there's that. But besides that, the other greatest challenge for wider adoption of secure multi-party computation is just the sheer complexity of it, right? Especially when we get into, like I said, what you would consider truly true secure multi-party computation, in which the participants not only don't know each other's input, but they can't access it either, right? And absolutely no third party is involved. It just requires a lot of resourcing to not only generate the protocols, but to implement them as well. An example of this is, I think about data clean rooms, in which it's the idea of like, oh, we are de-identifying user data for other companies to use, but it's still using a third party, right? Potentially that data clean room is a third party. So it's getting there, but it's not quite there. And as you can see, like in some of the other examples we talked about, when we try to get to like, not only do they not have access, not only can they not see the input, they can't access it. And we are also checking to make sure that the input is legit. It starts getting really complicated, right? So I think that's one of the biggest challenges. However, in my research for the blog post, I already came across folks who are trying to synthesize some of the concepts and protocols of secure multi-party computation into reusable primitives. The idea being that you can then kind of use it like secure multi-party computation as code kind of thing, which I think demonstrates that there is an interest in it and there's a desire to use it, right?
Yeah. Yeah, that's really interesting because, as you've been talking about this, it feels like as sort of, someone fairly new to this and hearing you talk about it, it sounds like it's really interesting technology, potentially solves some really difficult problems, but there's a significant amount of like customization for each use case. But if you can distill this down into some sort of primitives that then it's more like, Lego blocks essentially that you're stitching together to create something new to solve like each problem, then that potentially is the thing that really unlocks this. And I also, clean rooms I think is a really interesting potential application area as well. And it's something that there is a lot of buzz on, and we need to probably do a full episode dedicated on
yeah.
So how far do you think we are away from actually seeing this being more widely adopted?
Right. So like I said, there's already folks who are working on this. My hat's off to those folks because I'm like, this looks very complicated. But that's what's kind of amazing about humans is they love challenges. So I don't know how qualified I am to predict trends in technology. And I confess I'm kind of an optimist. Like I said, I believe in humans and their capabilities. But I would be pretty surprised if we didn't start seeing more widespread adoption of this within the next 5 years. Like if it takes longer than that, I'll be a little bit surprised. And I think that some of the new privacy laws and regulations are going to help usher this in. In my reading, I came across about how a lot of browsers are going to be disabling cookie tracking. Like that's just not going to be a thing anymore. And so like whether you opt in or don't opt in, and then that question of like, okay, how do we get data for like, targeting ads and all that kind of stuff? Secure multi-party computation is going to become more important, I think, in that scenario, or, in this evolving privacy landscape, because what's going to have to happen there is like different companies, right? So maybe even potentially competing companies, they're going to have to need and get access to like another company's data, perform some kind of computation on it, right? But neither of these companies is going to want to share that, share either the specifics of that data or like the specifics of their computations, right? They're like secret sauce for advertising. So I think that's going to help usher this in.
Mm-hmm. And, in your research, did you find that is a lot of the innovation coming from academics, or is it more industry driven, or maybe there's a balance there?
I think right now it feels a little bit more academic driven. It has its roots in like very like, intellectual like places, right? Like there's a whole bunch of papers out there you can check out. And I imagine that a lot of it was developed for like research, right? Like because the idea of like how do we use the data, potential, private information for individuals, but come out with some kind of meaningful conclusions or computations. So it feels a little bit more academic right now, but I am sure that will change very quickly.
Yeah, I think as there's more like as you mentioned, there's more privacy regulations around the world, then that creates business incentive for wanting to invest in technology like this, which then creates a business incentive for developing technology like this. So what once started as an academic thought experiment around the professor lunch room talking about doing poker in your head, fast forward 30 years later, suddenly starts to become maybe it's a $1 billion industry for some sort of budding startup out there.
Well, somebody develops an app that's for billionaires to go to dinner and figure out who pays. They're gonna.
Yes, there you go. Exactly. So going beyond secure multi-party computation, what other technologies in the data privacy space are you particularly excited about?
I don't know if I'm as interested in the technologies as I am in the people. It's a really interesting space right now, I think. I recently had the chance to participate in a panel discussion organized and hosted by IAPP, which is the International Association of Privacy Professionals. And in my preparation for that panel, I met with a couple of other privacy folks in the field, and everyone really, ironically for privacy people, they're also really happy to share information, right? And share their thoughts about privacy and share their expertise and share their experience. And it's a really fascinating space, I think, right now, because as I mentioned at the beginning of the podcast, there is this tension between like the right of the individual to privacy, but the potential of data. And so, there's going to be lots of different technologies that evolve in response to this question. But I think that the most important part and the most interesting part to me is the people involved and the people leading these technologies, right? And the reason why that's so interesting to me, and I think we're beginning to see this in artificial intelligence a little bit, is like, who are the leaders and how are they deciding what's okay? And where is the diversity of perspectives that we need in order to form like truly inclusive, holistic, respectful privacy, privacy laws, privacy regulations, privacy strategies, right?
Yeah, and there's a lot of, we're in the like hype cycle right now of Chat GPT, and there's certainly a lot of conversation around the potential for bias in AI, and that's something that we've touched on the show as well in the past a couple of times. I do want to make a note there too of what you mentioned about how your experience essentially with the privacy professional world is a very inviting one where people are willing to share their knowledge and their thoughts, and that's something that has come up on the show in the past as well. And I think it's something I like to draw attention to, because it is kind of a small world of privacy professionals out there, but they're really like passion driven folk that care deeply about the topic and are happy to invite you into their world and share their knowledge and expertise. So as we start to wrap up here, is there beyond your blog post, what would you recommend someone interested in this topic? Like, where should they go to learn more about it?
Oh, there's so many places. I mean, I hate to say this, but Google is a great place to start. There's so much information out there about it. I would say if this is your first time with this topic, to be gentle and compassionate with yourself about it. Because I know for me, it took a few stages of reading the same thing over and over again before I finally understood, right? And that's okay. That's part of the learning process. I know a lot of us in engineering, a lot of us who have been developers, who work in tech, we're kind of hard on ourselves. We want to know everything right away. And because a lot of us are pretty smart, a lot of times we do get it right away. But be patient with yourself if that first pass, it doesn't quite make sense and it's still a little squishy in your brain. And to that end, don't be afraid to ask questions. As you said, the privacy world is pretty happy to share. We're actually not trying to keep secrets. And I don't know, maybe we should have a discussion about it in the partially redacted community, on the Slack channel or in the Slack. That might be a good place for it. But just start with a good old Google search, and be patient with yourself, because it is kind of a complex topic. And it's going to take a couple of exposures before it makes sense. And don't be afraid to ask questions, because people are really happy to answer. Yeah,
that's a great advice. And for those that are listening and do want to ask questions or connect with Liz, you can connect with her in the partially redacted community, as she mentioned, at skyflow.com/community. And well, awesome. Thanks for coming on, Liz. I love learning. This podcast is in many ways my selfish way of getting people to spoon feed me new nuggets of learning every week. So thanks for indulging me. I'm sure we'll have you back down the road to talk about something else. So cheers, and thanks for coming on.
Awesome. Thank you so much for having me, Sean. This was really, I was very anxious because I wanted to do a good job, and I hope that, I hope the listeners got something useful out of this, and because I love teaching. So yeah, looking forward to next time.
All right. Thanks. Bye.